All right, everybody. So next week, you guys are going to have a test over conics. And what I'm going to be reviewing today is all four parts of the conics. Starting off in your first page of notes, you have parabolas, and I talked about focus points. Remember, with a parabola, let's just take a basic parabola. Let's take something like this. Remember, your focus point is inside your quadratic, and your directrix is symmetrical. If I went up, let's say 4 units, I would go down 4 units, and I would have my directrix line. And at any point that is on this quadratic, it is equidistant from the directrix to the focus, and it has to be perpendicular. So that's a review. And then this was the weird thing. This directrix had that weird equation, and the equation was h comma k plus 1 over 4a for the point. And it had to be written, you had to have the quadratic written in vertex form in order to figure out what the a is and the vertex. Okay, and then I sit and I tell you, graph something. Now this was the weird one. Remember, I'm going to do x plus, this is the equation, 1 over 8 y squared equals 0. Okay, just for the sake, I'm going to rewrite this up here. X plus 1 over 8 y squared equals 0. Now what I'm going to do, remember I told you guys, the way to do this is to flip the x into y. So I'm going to change this. I'm going to flip this. And I'm going to have y plus 1 over 8 x squared equals 0. Because this is something that I'm used to seeing. All right. I'm going to move this whole thing over. So I have y equals negative 1 over 8 x squared. Now this is moved over. Now I can graph this. So if I were to graph this, my vertex is 0, 0. So my h is equal to 0. My k is equal to 0. And my shape is equal to negative 1/8. Okay. So now, here's my vertex. I'm going to go down an 1/8 over 1. So it's going to be a super wide quadratic. I'm ignoring this right now. I'm going to solve for my directrix and my focus if I just had this equation. So my focus is going to be somewhere in here. And remember, the formula is h comma k plus 1 over 4a. All right, I'm going to replace everything with these right here. My h is 0, my k is 0, my a is equal to negative 1 over 8. So if I were to multiply this, I'm going to get 1 times 1, which is 1. This reduces to 4 and 2. This is a negative though, so I'm going to have negative 1/2. This whole thing is going to give me negative 1/2. All right, so I'm going to replace, and if I'm going a little too fast, just rewind the video. Negative 1/2 all over 1. Okay, so this is, if I had to rewrite this, this is 1 over 1. This divided by the reciprocal, negative 2 over 1. I'm sorry, multiplied by the reciprocal. So this is going to give me a full thing of negative 2. 0 plus negative 2 is just staying at negative 2. All right, so 0, negative 2 is right here. This is my focus. My directrix is symmetrical, so I would go up 1, 2. Boom, there's my directrix. Okay, so my directrix would be y equals positive 2. My focus would be 0, comma, negative 2. But this is the thing. Remember how I switched these? I'm going to reflip everything now. Because my equation that I would graph is technically x equals negative 1/8 y squared. So this graph has these two flipped. This is going to be negative 2, 0. And instead of my y line, it's going to be an x line. Okay, now instead of turning this for the sake of the camera, because the camera gets all weird, I'm just going to regraph this. Negative shapes. I'm just going to literally take this and regraph it. This is going to look like this. Here's my directrix at negative 2, comma 0. Here's my, here's my focus. My directrix is x equals positive 2. Boom, right here. There's my equation. Or there's my graph if it asks me to graph this. Okay. The next is circles. Circles was probably the easiest thing to do. All right, so with circles, I give you the equation x minus a squared plus y minus k squared is r squared. But then you know your center is h and k, your radius is the square root of r. But then I give you a little more difficult equation to graph. I give it to you in before anything is before any square is completed. So what I'm going to do is I'm going to group my x's together first. I'm going to move that 24x to the other side by adding it. I'm going to group my y's together. And I am going to leave this negative 160 over here. Okay. All right, so I'm going to complete the square here, and let me put this over here, negative 160, and put it here. I'm going to find this number and add it over here. Completing a square, half of 24 is 12. 12 squared is positive 144. Factor this x plus 12 squared, okay? Plus. Half of 10 is 5, squared is positive 25, so add 25, add 25. And factor this, just becomes x plus 5 squared equals, all right. Now if I were to do negative 60, so I'm going to go 144 plus 25 minus 160. I'm going to get 9. There, it looks way easier now. My center is negative 12, negative 5, and my radius is not 9, it's the square root of 9, which is 3, because this 9 is the same thing as saying 3 squared. It's the same thing. And then you could graph this. I'm not going to graph it, but your center is negative 12, negative 5, and then go 3 units up, down, left and right from that. Okay, now we get to the more difficult parts, which is the ellipse and the hyperbolas. All right. Now for the equation of the ellipse, you have x minus h squared plus y minus k squared. But this is equal to 1. And then you have something new. It's called your, this has to do with the x-axis, so it's your horizontal stretch. This has to do with your y-axis, which is called your vertical stretch. Okay, and you square root both of these to figure out how many units stretch and stretch. Remember, ellipses are like ovals, elongated either this way or this way. Now I give you an equation. See if you can pause this video and try to graph the equation that I give you in the notes. 4x squared plus y squared minus 24x plus 33 equals negative 2y. Okay, let's see how you did. So I'm going to leave 4x squared. I'm going to group my other x next to it. Negative 24x. And I'm going to have positive y squared. I'm going to move that 2y over to get positive 2y. But then what I'm going to do is I am, do this, plus this is going to be a blank, plus this is going to be a blank. I'm going to move that 33 over to the other side. Okay, now what I can do is this. I can factor out a 4. But remember, when I factor out that 4, I have to do the opposite of multiplying, completing a square by this number. So if I factor out a 4, I get x squared minus 6x. Take half of negative 6, which is negative 3, squared, which is positive 9, and multiply that by that. Now I'm going to factor this 4. This is going to be x minus 3 squared. Same thing with this. I can tactically factor out a 1 because you have to have something to factor out. And you're left with y squared plus 2y. Half of 2 is 1. Squared is a positive 1 multiplied by this. And then I'm going to factor this. This becomes y plus 1 squared. Okay? Equals, this is going to be 36 minus 33 plus 1, which is equal to 4. Now, this, I can divide everything by 4. And then I clean this up. These cancel out to give me this is 1, and this is 1. This is minus 3. I'm just filling in with my equation. Actually, it probably won't say 1 squared. It'll just say 1. And then this is y plus 1, which is a negative 1 squared. And I have a 4. 4 divided by 4 is 1. So here's my equation. Now with my equation, what I do is I'm going to graph my center, which is positive 3, negative 1. My horizontal stretch is just 1 unit, 1, because I square root this, and that's my a. A equals the square root of this. 1 and 1. And then b equals the square root of this, which is 2. 1, 2, 1, 2. So it's going to look like that. Okay, the very last one is the hyperbola. Now, we went over this. This was the last lesson, so I'm just going to review how to graph this. I give you the correct foci this time. The correct foci is plus and minus c, comma 0. If the hyperbolas look like this. If the hyperbolas look like this, the foci is 0, comma, plus and minus c. But remember, your c is kind of like the Pythagorean theorem. C squared equals a squared plus b squared.